Hello and welcome back to Poor Man's Electronics Bench. Part 4 of this episode will cover my attempt to carefully remove and separate the two main boards, analog and digital, of my older LC53 Z meter. This work involves some patience and careful observation to ensure that you do not crack or damage the boards in any way and should not be rushed by any means. I carefully and slowly fumbled my way into a process that helped me successfully separate the two main boards, and they can be reassembled with a small amount of an anti-corrosive compound to help further dis- and reassembly. If this content and information is of interest to you, please feel free to continue viewing. And this is the part of the video where I'm going to make an omelet and crack a few eggs. I'm trying to get the board out of unit number 1 so I can start the recap work. And so you can see the most important thing is the unit is unplugged. There are no high voltage capacitors in the unit. Everything is, the only storage of any high voltage happens when you hook a capacitor up to the leakage test, and that voltage goes with your capacitor once you disconnect it. So everything else, it's below 35 volts. This one's a 50 volt capacitor. I don't think there's much on it. I could discharge it just for giggles, but it's probably fairly well discharged already. We have items laying around the discharge capacitors like that. And in the meantime, while that's hooked up and bleeding off to a resistor, I will give you a little tour of this one. These are the differences between the unit number 2, the newer unit, and this is that these have straight PCB pins coming up from they're down from the analog board to the digital board. And these are both double side trace boards as well. And they do have vias, they have connections sometimes that go from the through hole from one side to the other in order to make continuity, and it's kind of misleading because they list the board as a component side and a foil side, where it's both sides, or a foil side is just only one side has a component when they give a view in the manuals. So you have to pay attention to that part of it. And then these two connectors, like I was saying, there's PCB pins that go from one board to the other directly. They are held in place by a little solder ring on each board. There's one there, or it's not solder, but it looks like a copper wire ring. And then there's another one down here. And our goal is going to be to remove those. And none of these other connections are soldered. They all push right through to make contact, but they just have that. Each one of them has one of those rings on it too, kind of as a keeper, just to make sure that nothing silly happens from vibration or anything like that. I'm going to attempt to get a soldering iron in the mix here, put some heat on each one of these, and try to get them off. Probably wouldn't be the dumbest thing to put some fresh solder on there. Just a little bit. Looks like it's got a good flow of heat going through it. And presto. Oh, it's actually a little ferrule, which is a really good idea. So I just have to repeat that for the other. This is, I can't say if this one's easier than the other one or not, due to the fact that you don't need any soldering to get the other one off, but it looks like this is going to be a lot less complicated as far as getting wires in and out of things. I'll show you. I am going to take Unit 2 apart because I do want to change a few things, a few components on that as well. Oh. Okay. I kind of caught that ferrule in my lap. I know I have it, so. Yay, found it. Okay. If not, could even be a round piece of wire. So everything else is just unplugging some Molex. I don't know if they call these Molex or Phoenix connectors. They're similar. They're all only going to go into one place. You will have some complications as far as some single connectors. Like I said, we have one that goes from the board to the digital board to the back of the display. Take him out. We have another one that comes up from the other board that comes up through here, the red wire. And one more here. And this board should be fully removable. See, unlike the other one, Unit 2, there's a series of little, like 2 or 3 inch wires that are held into place between the two boards, so you can lift it up and swing it open, but over to access things, but you can't totally remove it. This one looks like you can totally remove it, which is great. And there are also some standoffs that go in between the two boards, so like this second screw, if you find it turning and not coming apart, that's because it has a has a standoff between the two boards. Some of these go directly to the chassis, other ones go to standoffs between the boards. Let me take a quick one more inspection to make sure. Oh, we've got another standoff here, right by that capacitor. And then take any note of any things like this. There's a little rubber vibration damper washer on both sides. I don't know if that's glued or fastened to the chassis or anything, but we're going to try to make sure that it doesn't get lost in the process. And I think this, oh, we have to do some separation here. That's right. See how this board comes up? You also have to start to separate between the two, or else you'll just be pulling the whole board out, because they're as you see, they're fastened together, and this one has all the switch assemblies on it. It can't come out if I pull all these switch buttons out. It will come out a little bit this way if I take all the wiring out. Probably could take both boards out as one piece and then separate them. Might not be a bad idea. Going to do that. And again, these are color coded, which is nice. It's a yellow, greenish yellow. That's a white. Here's a darker green. There's a heavy red wire that goes from that's your test lead, and then a black that goes to a common board return. There's a blue one here. And that may let me remove both boards together. Oh wait, we've got a yellow wire here. It's nice to have all this down on video so I don't have to take notes. And after I get everything untangled from the wires... Oh, nice. I suppose I could do that with the other unit, but this is kind of nice because I now have a gutted chassis and both boards. And if you ever needed to get access to your switch in any certain direction, luckily these switches are both in very good condition. You could remove the boards to do that. So we'll leave the guts over there because we have, except for one capacitor in the front of that board, we had those changed out. And then we do have our standoffs there. And I'm just going to take these and gently pry them apart. I hope. Maybe not. It'll take a little effort. They're moving, but not in a big hurry. There is a lot of friction imparted by those connectors, but they are yielding. Okay, one is loose. Have to work our way over to the other side of the board. There's no good way to do this. It's just... I don't want to have it let go too fast, but you do want to make sure that there's nothing holding things together that should not be. And as far as I can tell, I don't have anything like that. Just trying my best to not crack the PCB by doing any of this. That would be fairly disastrous. Give it a little wiggle and put a little pressure on it. Oh man. Trying my best to resist the urge to use any type of tools. That'll only put more pressure on the board than it needs. Okay, if I could start. There we go. Pushing from one end, I'll do that a little on the other end now. Oh, man. Almost got the pins out on one side, and on the other side it's still stuck very well. Man. think I've got a little piece of solder maybe on that pin. I might have to push this guy back in. Yeah, I've got a little ball of solder. That's going to hold it from going through. To get some braid on there. I didn't examine that closely enough. So what to watch out for there is just a little clump of solder right there that'll keep that pin from going through, and I'm glad I didn't try to force it anymore. It looks better. I don't know if I got it all off. Got a little bit on the wick. I'm going to cut myself a clean piece of wick and try it one more time. It's got a tiny bit more off. Okay. This is one of those things you just don't want to be in a hurry to do. It's not a bad idea. I use my needle nose pliers as a spreader right between the points on the pins, and still feels like it's hanging up a little bit. Oops. Boy, oh boy. This might be one of the best ways to go about doing this, but boy, this is... There we go. Finally feels like it's yielding some results. Come on. Oh man. At least I'm putting pressure locally right on where I want things to move this way, which I like. Ah, oh, man, almost. There, oh, there we go. Son of a gun. Well, there really wasn't any extra solder. These just had quite a grip on there. I can feel some little metallic shaving just from the grip of what they had between the connectors. There is a lubricant I can put on there. I will consider it, and then just take a quick cursory look at the bottom of the board, and then give it a good inspection with a magnifying glass. Considering that this was working fairly well, it had one issue in calibration. I think that's just because I did not have the right value of inductor. Everything, even from the 1970s, these have been cut after the components were soldered. And surprisingly, there is no corrosion on the ends of anything. Some people have that as a concern when doing kits and soldering, but these are all cut after they were soldered, and I really don't see any remarkable green corrosion, anything, which is kind of neat. So I'm probably going to go ahead and start doing the recap. This one has the greater number of capacitors on it, the small value ones. Oh no, yeah, this one has a few. The other one has a few as well, and then then I'll go, the other one's got the bigger ones, and I'll do the one on the display board, and then go from there. I'll probably maybe clean these pots up as well. This probably wouldn't be a bad time to consider putting in some 5 or 10 turn pots. Looks like there's a space for them, and these are mighty hard to adjust from a side angle. They're in the unit like this. You have a hard time getting a screwdriver in from it like that. You cannot get anything in from the back because it's facing the back panel of the unit. They might consider some 10 turns. I'll see if I can size these up for through-hole component replacements and see what kind of stock is available and consider them for some 10 turns. So the next time you see this, it will have new capacitors on it. And in preparation for the decapacitation, I ended up just going through and taking a black Sharpie and making all my own little black marks on the board on the negatives. This way there's no confusion as to whether there's a bad board marking or not. Every capacitor's got a black spot on the negative, including the 2 big ones, so when I go to reinstall things, I should be able to do it without any mishaps. That is my plan, so I am going to go forward with that work. I am going to call an end to part 4 here. Part 5 will cover some schematic errors I found, and will also cover the work on replacing the original adjustment trimmer potentiometers with new 25 turn components in this unit. If you like this content, please give it a like, and if you want to be notified of more content and information on working on these Sencore LC53 units, please feel free to subscribe. I hope you enjoyed the video and return soon. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.